Transpiration is the process by which green plants lose water from their surfaces as water vapor and thus cools itself down. Now, tell me something. Is transpiration occurring at a constant rate at all the places throughout the year? Well, no. Transpiration is dependent on many environmental factors. 80 to 90% of transpiration happens through the stomata. Now, see, just like school gets open during the morning time and closes during the evening, stomata opens during the morning time and closes as the evening approaches. So the rate of transpiration is much more during the mornings and maximum at the afternoon than in the evenings. Sunlight regulates the opening and closing of stomata, and thus the rate of transpiration also varies. Now see, during the afternoon time, when the light intensity is maximum, the rate of transpiration is also maximum, but the rate of absorption of water is not as much. It is not enough to counterbalance the rate of transpiration. So, the plants wilt. But as the evening approaches, the light intensity decreases and so does the rate of transpiration. Hence, the rate of transpiration is less than the rate of absorption and the leaves become erect once again. Now, during the summers, wet clothes dry very quickly. We all know that. Why does it happen? This is because of the greater evaporation that takes place in high temperature. Since transpiration is also a form of evaporation, the rate of transpiration increases during summer. So rate of transpiration is directly proportional to the temperature. Greater the temperature, more will be the rate of transpiration. Now, let us perform an experiment to find out the rate of transpiration. For that, take a potted plant, water it, and wrap the soil surface to prevent evaporation from the soil surface. And put this arrangement on a weighing machine and monitor the weight for 3 hours. See, there is gradual decrease in the weight. Let's recapitulate this experiment once again. First, we poured water on a potted green plant. After that, we covered the soil surface to prevent evaporation from taking place. And then we had put this arrangement on a weighing scale. With time, over 3 hours, we saw that there was gradual decrease in the weight. So from here, we can find out the rate of transpiration. Because the decrease in the weight was the amount of water lost from the leaves and the plant. So the amount of water that is lost during transpiration per hour can be measured through this experiment. That is the rate of transpiration. We can also measure the rate of transpiration through Ganong's potometer. This instrument that you see underwater is the Ganong's potometer. First cut a rooted plant under the water and fit it in the sealed mouth of the potometer. Adjust the screws and take the potometer out of the water, sealing the end with your finger. Now release some water to introduce an air bubble and put the end of the tube in a beaker full of water. Now with time, the bubble moves through the capillary. Now notice the readings on the capillary. So this experiment we performed to find out the rate of transpiration using the Ganong spotometer. Now for that, we cut a rooted plant under water. Now we have to cut this rooted plant slantly so as to increase the surface area for absorption of water. Next, we fit this twig on the sealed end of the Ganong spotometer. After that, we had taken up the Ganong spotometer and introduced an air bubble into it, and then kept the end of the Ganong spotometer in a beaker full of water. Now the green plant will transpire. So with transpiration, a water suction force is created that pulls the water from the beaker and the bubble along the water capillary. Now the reading of this capillary will give you the amount of water lost during transpiration. So from here, we can calculate the rate of transpiration. Now, this process has a few limitations. What are they? First of all, the introduction of the air bubble is not very easy. A lot of care has to be taken to see that the air bubble is inserted into the water capillary. Second, the twig may not be fully alive for that long because we were measuring the rate of transpiration for quite some time. Now, the twig can die within this time. So, care must be taken that the twig is alive because only a live twig will perform transpiration. The third limitation is that any change in the outside temperature might affect the change in the position of the bubble in the capillary tube. During the monsoon season, we often see that clothes do not get dry easily even during the afternoons. Well, this is because of the high humidity or the greater water vapor concentration in the air that the air cannot take in more water. So, the rate of transpiration also decreases. Now, transpiration is a type of evaporation, and so it depends on humidity or water vapor concentration in the air. Now, during the monsoon season, clothes dry up quickly if you put them under the fan. So similarly, the rate of transpiration also increases with greater wind velocity. So greater the wind velocity, more will be the rate of transpiration. So these are the 4 environmental factors that control the rate of transpiration. Now, another important factor that controls the rate of transpiration is the availability of the soil water. What do I mean by that? Now, take an example of these xerophytic plants that you find in the deserts. Now, these xerophytic plants have very less water to take up from the soil because the soil has a very less amount of water. So since they absorb less water, the rate of transpiration is also less. So this is an important factor that alters the rate of transpiration. More the soil water, more will be the transpiration. Lesser the soil water, like in the deserts, lesser will be the rate of transpiration. Now, an important and interesting fact is that oaks, which are found at higher altitudes, transpire a lot of water. They transpire about 40,000 gallons per year. Well, what is the special reason behind this? Well, it is seen that in higher altitudes, the atmospheric pressure decreases. Now, as we know, transpiration is a type of evaporation. So, the rate of evaporation of a liquid increases as the pressure on it decreases. So, similarly, mountainous plants like oaks transpire greater as the atmospheric pressure is lesser. So these are all the controlling factors that controls and alters the rate of transpiration. Light, temperature, humidity, wind, soil water, and atmospheric pressure. These are the factors that cause the change in the rate of transpiration.